of you here. Then co-chairperson Khilana Da and rapporteur Arpan Pradri. Now I hand over this mic to the chair and we start with the presentation. Then you will handle the rest of the session. Thank you.
Thank you very much, Ajay. Welcome all in this session. So we will be going through several articles. And each presenter will have a time of around 12 minutes and then 3 minutes for question and answers part. So I request all presenters to stick on the time, and I will remind you once we reach near to 12 minutes. And the first presenter is Menuka Gautam.
PhD scholar from Central Department of Geology, University. User prospect and economic value, conclusion and differentiation. Introduction. As we know that Nepal is rich in water resources, so throughout the country, water resources are abundant in the form of rivers, spring, lakes and groundwater. In spite of water resources rich country, due to the lack of preservation and protection of springs, the problem of acute shortage of water in the region has outbreak and challenged the people's daily life. The scientific research and scientific plan for utilization preservation should be carried out. Present research was carried out for identification of groundwater protection zones with impact of mineral structure on groundwater prospect. As we know that my field study has been carried out in Siwalik zone and very less part of Western Himalayan zone, and field study has been carried out from Narayan to Lothar Khola and Bagmati province, Chittor district, and the village carried out was Jugedi, the Hakhani, Saptikor, Khorak, Bidanagar, and total area cover was 250 kilometers square. The main objectives are groundwater assessment of Chittor Valley on the basis of geological structure and hydrogeomorphology, preparation of groundwater protection map, study of linear relation between the multiple buffer zone, MBT, and spring occurrence. Methodology. First, I have study and literature review has been done. After then, planning has been carried out and field study has been done. In field study, I have taken primary data and secondary data has been taken from DEM, satellite image and Google Earth. And by combining primary data and secondary data, lithological map, geographic map, dams map, dynamic map, slope map, aspect map, drainage density map, and GPI and DWI, TRI map has been prepared. And with the help of ArcGIS 10.2, groundwater protection map has been prepared and validation with this field has been done. Result and discussions. As I take on the data of electric conductivity, and the value of electric conductivity has been increased towards Siwalik, from Siwalik zone towards the lesser Himalayan. It is because of large number of minerals ions dissolved in lesser Himalayan zone, and discharge rate on the basis of magnitude of major classification has been done, and the magnitude has been find out 6, 7, 8. And linear regression has been carried out between distance from MPT and discharge with response to types of spring and formation, and contact springs have less discharge than factory springs. So we find that a factory spring has a large discharge and within the distance will be very close to main boundary thrust, and the regressions plot show that the value of R square is 0.04, and we show that the distance with discharge is very weak correlation. Then I have prepared GEM map and reset map. With the help of GEM reset map, slope map and ascent map has prepared, and slope map has been classified on the basis of very gentle to the very steep map, very steep slope, and very steep slope has a chance of more ground surface runoff, then flat slope alpine, more groundwater recharge. So on an aspect map from flat to north aspect, and in from flat to north aspect have more chance of groundwater occurrence than south aspect, because in south aspect there will be the more prolonged chance of sunlight than north aspect. And spring density map has been prepared, and we can see that spring density are high along the fault, like main boundary thrust, central surya thrust, tire thrust, and we can also see that spring line along the thrust. So geological structure has a major role in groundwater occurrence as well as recharge as well as storage also, and multiple buffer zone has been prepared along the main boundary thrust up to 12 to 6 kilometer. Linear regression has been plotted along the multiple buffer zone of main boundary thrust from 0.6 kilometer to 12 kilometer, and up to the buffer zone of 0.6 kilometer. The value of R is found 1. That means it is a perfectly correlation, and after the distance is increased from main boundary thrust to 12 kilometer, the value of R is decreasing to negative value. So it is strongly negative correlations. So this shows that main boundary thrust play a major role in spring occurrence. And I have prepared a flow direction and flow occlusion map. From that I have prepared stream, and from stream drainage map, and from drainage map I have prepared drainage density map and classified into low, moderate and high. In low drainage density help in infiltration of rainwater, whereas high drainage density help in surface runoff. After the geomorphological map has been prepared, and it is classified on a high dissected structural hill, isolated hill, low dissected denudation hill, linear ridge, medium dissected denudation hill, low dissected denudation hill as recent deposit, and high dissected structural hill, and play a major role in groundwater occurrence because due to the high dissected due to the fracture and fall zone, it helps in groundwater recharge. Then denudation hill. After that, I have verified this geomorphological map with the satellite image. I have prepared a land cover map and cultivations, ponds or lake, river, streams play a major role in groundwater recharge. Then settlement, bush and forest. And I have also prepared a geological structural map called central surya thrust, tire thrust, and main boundary thrust. And I have overlaid this geological map with a major geological structure, and the geological map is prepared by DMG 1987. And I have prepared an NTWI map with the help of satellite image, and it's classified into very low to very high. And very low has a low chance of groundwater, and very high has a high chance of groundwater occurrence. And topographic roughness index has been prepared, and it is also classified into very low and very high. And very low has a high chance of groundwater occurrence because of smooth land surface, and very high has a low chance of groundwater occurrence because of surface roughness. And VI map has been prepared, and very low has a high chance of groundwater occurrence, and very high has a low chance of groundwater occurrence. And finally, what is the rank of classes is assigned according to the rule of groundwater occurrence of various thematic layers, and higher weightage is given to dynamic density map and is dominant because we have seen that 4 has play a major role in groundwater occurrence. This is the final output, and groundwater potential map has been prepared, and it is overlaid with springs and dynamic, and we can see that more springs were found along the fall zone, and groundwater potential also high along the fall zone than other splashes. And I have validated with RC curve, and it is 0.74, that is 70%, and is moderately validated. And I have prepared pie charts, and low groundwater potential zone as 8%, moderate at 39%, and high groundwater potential zone as 53%. And future prospect and economic value. It was studied that only if pre-2019 Nepal has abundant water resources with many concentrated use of potential export commodity for years. Discussion about exporting Nepal's crystalline water to water-scarce nation started long ago, but logistic and political challenges delay actual implementation. A government initiation was done in 2019, and in June 2019, the Nepalese government officially began preparations to export drinking water. The Ministry of Industry, Commerce and Supplies identified 13 potential water resources for export, focusing on market in Gulf country. And conclusion, in the study area named as main boundary thrust Guide thrust, interfluent thrust, and local fault play a crucial role for groundwater occurrence. The number of spring decrease at distant increase for MPT in a relation R is equal to minus 0.65, so it's totally negative correlations. Similarly, the distance rate between main boundary thrust and distance has been found as R equal to 0.0632, so with very weak correlations. As groundwater potential map is prepared by integrating thematic layers such as geomorphology, land use aspects, rocks, not rock soil, and moderate high groundwater potential zone. Himalayan water can be a good export for product for increasing national economy differences. Thank you so much.
We have time for two very short questions. At least we should get one question from the audience.
Came late to watch your presentation, but I could take one note. The number of springs decreases as the distance from MBT increases, right? That one really struck me because the groundwater. So in your study, have you characterized the spring types? What different types of springs do you have? And how these different springs distribution varies with MBT distance?
Yes.
Thank you.
I have found fracture spring, contact spring, and depression spring. And depression spring are more found in Siwalik zones, and fracture springs are more found in lesser Himalayan zone. But they have no very weak correlation with the main boundary thrust. Discharge and spring types have weak correlation with the main boundary thrust. Only number of springs are correlated, and they are high in around the buffer zone of main boundary thrust.
Thank you.
Thank you very much. And now I call upon the guest, Brunei
Good afternoon, distinguished guests and fellow researchers. It is an honor to stand before you to present my PhD research under the supervision of Dr. Motilal Vishal and co-supervision of Dr. Gopal Vishal. The presentation overview is introduction, research objectives and scope, methodology, result, conclusion and recommendation. I would like to start from introduction. What are springs? Springs are natural flow of groundwater emerging at the earth's surface in various geological settings. So the significance in Nepal Himalaya is very much appreciated. It's essential fresh water sources, particularly in the middle region in the study area. The study motivation is the water quality that is affected by geogenic and anthropogenic influences requiring detailed assessment. Since the water security is a growing concern globally, and in Nepal, middle regions, springs are the lifeline of local communities. It is used in drinking, agriculture, and many more activities. However, they are drying, and the water quality of these springs are degrading. So the research is in the study area is in Kandiki province in the Parbat and Sangja district. The map shows the region, map shows the area of the watershed, and it covered the area of 115 square kilometers. The sub-watershed and major villages are mentioned here. I'm going to skip this part. The research objectives and scope of this part is assess the water quality of selected springs. One is this. Another is analyze physico-chemical parameters and identify hydrogeochemical characteristics based on geological influences. Since this is the work that haven't completed yet, it's running its ongoing process. One time water quality has been taken, and another part will be taken in the lean period. So this value, all given values are based on the winter season that I have taken in last 2 months ago. Before the methodology of the sampling is out of 175 springs that are perennial springs that I have observed, that I have studied during the whole this research. Out of them, 66, I have selected 66 for water quality analysis, and some of them and exact that values were sent to the isotope study. the results are coming on the way, and they are transported from the spring source with standard procedures. That is, some of them are airtight water bottles in 1 liter sampling containers. You can see in the map that highlighted region is the green. Light green is non-carbonate dominant rocks, whereas dark color is carbonate dominant. Similarly, for the selection of springs criteria, I have developed several criteria based on land cover by ICMOD, soil cover by FRDC, which is Forest Research and Training Center, and similarly slope depth aspect from depth. The methodology, in the methodology, the parameters analyzed were pH, EC, TDS, turbidity, major cations, calcium, magnesium, sodium, potassium, iron, ammonium, bicarbonate, chlorine, sulfate, phosphate, hydroxide, and nitrate. And the data analysis were done on the basis of comparative assessment between carbonate and non-carbonate dominant lithologies. These are the equipment, these are the laboratory procedures and the equipment used in the lab. Some of these instruments are, you can see the references and methods used as on the table. And the results and discussions show that the concentration of the ions are higher in calcium for cation, whereas bicarbonate higher for the anions. Similarly, this follow other anion and cation follow the train. We can see in the graph also, graph as well. The carbonate terrain has lesser values, whereas the non-carbonate terrain has higher values. And we can see from this diagram, from this graph, that suitability and unsuitability of the water, especially for irrigation, that is magnesium hardness. Magnesium hardness is calculated, and different scenario was observed. That is, we have several formations like Bengal Slate, Dhading Dolomite, Nodana Quartz. Similarly, other formation as well. The Dhading Dolomite is the most dominant in the region, whereas Bengal Slate and other follows the Dhading Dolomite. In the Dhading Dolomite, we can see that unsuitability is lesser, especially in all the cases. Unsuitability is lesser than the suitable sources. And for this is for especially for irrigation, non-carbonate rocks hold 30 suitable for irrigation, whereas unsuitable for irrigation are 6 springs. And in the carbonate terrain, there are 21 springs suitable for irrigation, whereas unsuitable for irrigation are 10. And the other dominant part are parameters are nitrate, ammonium. Nitrate is present in 3 carbonate dominant rocks, whereas 6 springs, non-carbon dominant region in 6 springs. Value is the highest in Nodana quartzite, range from 0.1 to 3.2 milligram per liter, similarly from ammonia. And iron also found in detected in 10 springs, whereas 3 in carbonate terrain, whereas in 7 in non-carbonate terrain. Manganese were not detected in any samples, which indicate that host rock springs coming out from that host rocks they had not the manganese elements. The primary influence are interaction of spring water with carbonate and associated rocks, which affect the concentration of specific ions in carbonate ecology, and it signifies that understanding these interactions helps in groundwater resource management. So I want to conclude here because the remaining portions are still on the way. I have to take samples to the lab, and I will take some results later, and I will compare the results from dry season and wet season. In the conclusion part, the water quality varies based on lithology. One is that major part is that, and carbonate springs shows higher geogenic and anthropogenic concentrations. Iron concentrations observed in certain non-carbonate springs, and manganese absent across all samples. From this study, until now, I have recommendation on regular monitoring of spring water quality, investigate potential anthropogenic influences, and sustainable management strategies for freshwater conservation. Thank you, and I would like to acknowledge lab facility for wastewater quality assurance division, Kathmandu Nepal Limited, and lab work support for Ms. Nikita. Thank you.
Thank you for being very effective in your presentation. So now the floor goes to the audience. So anybody has any questions? There should be many colleagues. Have any plan to do the more measurement of the springs in a month or like so that you see the variation?
Yeah, I have taken in situ samples, in situ parameters 4 times in a year. In situ parameters, which includes ECTDS, BS, ORP, and temperature. And whereas water quality for only this year, last time in 2024, and next year
If you have any questions from the audience? No. Okay, so please. Yes.
Based on the discharge of the formation, you are quantifying everything here, right? Based on the discharge, which formation the discharge. Have you divided the study area into counter basin or smaller counter basins so that the source water and the discharge water, how far it will travel before it gets discharged to the ground? Have you studied that?
For this part, not exact, because the water set is, I have taken water set as smaller unit. As we all know that we have to take value to value approach for this spatial management, but it's quite expensive and during some of the constraints. I have taken the samples, and I have one thing that plan is isotope analysis. That I have taken samples of the lab, and I can identify the recharge area from the isotope results, so that we can identify isotopes, where is the recharge area, and we know the discharge area, and estimate the potential.
So based on that, so the result, rather than the discharge formation or the recharge formation, which is contributing more to the chemical composition of the groundwater?
For the chemical composition, it's still have to research, but I have discharge part section, discharge different parts that have submitted to another research, and this is different part, and I will compile this both, and I think we will have some interesting results.
Invite Nikita Pade. She is going to present variation of iron in groundwater and its impact on human health.
Moving forward to the outline of my presentation. And starting off with the introduction, the groundwater is a significant water supply sources for the domestic, municipal irrigation and the industrial purpose. Talking about the context of the Tarai region, 90% of the people rely on the groundwater sources for their potable water using, and the iron is one of the important constituents present in the water, but if its concentration is in the high level, it is not only for the impact for the environmental issues, but also the concern of the serious health risk. And the one study area lies in the Tarai plain of the Kailani district, governing the two municipalities, Godavari municipality and the Dongari sub-metropolitan city. The groundwater resources present in the area are used in the form of the hand pump, artesian well, and the boring sources. The groundwater resources is divided into the shallow and the deep sources in terms of the depth of the water. In the shallow sources, using from the hand pump and the boring, and in the deep sources, people were using the groundwater in the terms of the hand pump, borings, and the artesian well. The objective of my resource work is to
determine the concentration of the iron, to investigate the sources of the iron concentration, and to determine the impact of the iron concentration in the human health. To meet this objective, various methodology were applied in the field. Firstly, the well inventory and the questionnaire session survey is conducted through the local swan to find out the health impact and the different groundwater sources present in the area, and the in situ measurement is done in the field, and after that the sample collection is done, and the sample, after the completion of the sample collection procedure, it is for the laboratory analysis. It is conducted in the laboratory of the KUKL for the physiochemical analysis. The physiochemical analysis is done for finding out the suitability of the drinking water according to the anti-WQS and the WHO guideline, and the suitability for the drinking according to the WQI, and to find out the hydrogeochemistry of the area using the pipe of Gibbs and the Gibbs diagram. The iron is measured using the photocalorimeter instrument, and in the laboratory the iron is the presence of the iron is checked by using the different kinds of the reagents like the hydrochloric acid, hydrochloric acid, and if the iron is present in the water sample, it shows the color of the water from the pink to the deep red color. It can be shown in the figure. A total of the 50 water samples were collected for the laboratory analysis, 29 from the shallow sources and the 21 from the deep sources, including 10 from the HIPOM and the 11 from the artesian wells. Talking about the hydrogeology of the study area, a total of the 5 deep wells were the inventory. Their depth relied from the 32.6 to 56.1 meter, and the sediments type of the area is from the sand to the gravel, and the best zone for the extraction of the groundwater resources is the deep well number 1 and the 2, that is from the southern part of the study area, which covers the Dalgari area. The uses of the groundwater is mainly hand pumps and artesian wells is used for the drinking and the household purposes, and a part of it is using for the irrigation and the industrial purposes. And talking about the borings were mainly used for the irrigation and the farming purposes. And from these uses, it can be concluded that the people of the Dalgari area rely on the groundwater sources as for their drinking purposes. So this study covers the iron and what is the concentration of the iron and its impact in the people's life, and the hydrogeochemistry of the area. From the Piper diagram, it is concluded that the calcium magnesium bicarbonate types, and from the Gibbs diagram, the hydrogeochemistry of the area is governed as the rock dominance. And moving forward towards the concentration of the iron in the area, the first one figure shows the standard concentration. Out of the 29 samples, 24 samples shows the presence of the iron, ranging from the 0.17 mg per liter to the 9.86 mg per liter. Here in the figure, the two samples, SS5 and the SS7, were in the permissible limits according to the anti-WQS, that is the 0.3 mg per liter. And other than all the parameters were out of the limits as the anti-WQS limits. And talking about the deep sources, only the 8 sample sources show the presence of the iron, ranging from the 0.17 to the 7.14 mg per liter. And here also only the 2 samples were in the permissible limits according to the anti-WQS. And this study shows that the shallow sources contain the more percentages of the iron. That is due to the shallow sources will rely on the more agricultural activities. Moving forward towards the concentration of the iron is maximum in the northern part of the study area, and this figure shows the sample sources collected on the high percentages of the area SS2. We can see the redness of the land caused due to the presence of the iron collected over this area. And this is the hydrogeology of the area. That's in the northern part of the study area. There are the sediments of the gravel. Due to the sediment type of the gravel, which can bear the iron containing minerals. So in this area, due to the hydrogeology of the area also, the iron concentration is high. And according to the WQI, we included with the iron, its value ranges from the 1.985 to the 446.70, concluding at the 38% of the water were the unsuitable for the drinking. But when we exclude the iron while using the WQI parameter, the value ranges from the 2.10 to the 122.22, and it gives the result that only the 8% of the water sources were the unsuitable for the drinking, and it concludes that the iron is the most important parameter that regulates the water quality in the area. And the different sources of the iron found in the area are the natural source, like the iron bearing rich minerals, anthropogenic activities like the agriculture and the industrial activities, and due to the hydrogeological condition of the area. The health impact of due to the excessive iron in the area in the short term, it can cause the diarrhea, the reddish brown color of the water, and if it is used for the long term, it can give the chronic consumption like the liver and the heart disease. And while doing the inventory, the people were also says that they were suffering from the disease like the kidney, liver disease, and this can be the cause of due to the iron. And the groundwater, this is the picture shows the groundwater condition of the area in the pre and the post monsoon season. In the post monsoon season, the flow of the groundwater is high as the pre monsoon season, because this is due to the rainfall condition. In the dry season, the rainfall level is the low as compared to the wet season. To conclude my presentation, the groundwater is used for the 36% for the drinking, 38% for the household, 10% for the irrigation, 5% for the industry, 8% for the fish farming, and 1% for the poultry farming, and 2% for the fruit farming. And the iron is the major factor that degrades the water quality in the area. And the most of the shallow sources were found to be the containing of the more iron concentration. And according to the hydrogeology and the groundwater chemistry of the area, the iron is influencing more in the area. The WQI drastically worsen if the iron is considered, that is the 30% of the sample were the unfit for the human consumption. And the recommendation are that the effective analysis and the monitoring of the water quality need to be done. Community education and the water control measures treatments should be done in the area to address the high concentration of the iron. And I would like to acknowledge my supervisor, Water Waste Quality Assurance Division, Mahakanto, UPS, President Sri Mandestara Conservation Board for this research camp, and thank you to all. These are the people who are using the groundwater sources using for the drinking, household, industrial, irrigation, fish farming, different purposes in the area. Thank you.
Very good. Wonderful presentation.
तपाईँले जुन आइरन कन्सन्ट्रेसन निकाल्ने केमिकल हालेर गरेको जुन मेथोडोलोजीमा कति कन्फिडेन्ट हुनुहुन्छ, त्यसमा पानीमा भएको अरू केमिकलले तपाईँले गरेको मेथोडोलोजीलाई कतिको इन्फ्लुएन्स गर्न सक्छ, त्यो एउटा हेर्नुभयो कि हेर्नु भएन। अर्को कुरा, तपाईँले आइरन नै सबभन्दा त्यहाँ बढी कन्टामिनेसन गर्ने अथवा पोल्युसन गर्ने कुरा हो भनेर भन्नुभयो। त्यो एरियामा चाहिँ पश्चिम नेपालमा अब पुरानो स्टडीहरूमा त्यहाँ आर्सेनिक लगायत अरू पनि टक्सिक इलिमेन्टहरू त्यहाँ छन् होइन। अनि तपाईँको अर्को कुरा, गोदावरी धनगढीको गर्नुभयो, तर माथिल्लो बेल्ट फुटहिलमा पनि बढी देखियो, तर तराईमा पनि बढी, हावर जोनमा चाहिँ एकदम कम देखियो। त्यसको केही एक्सप्लेनेसन दिन सक्नुहुन्छ? थ्याङ्क यू।
नर्दन पोर्सनमा देखेको छ भने चाहिँ हाम्रो माथिको बाटो जुन त्यो रकहरूको सेडिमेन्ट्सहरूको जुन फ्लो भएर आउँछ नि वाटरले गर्दा, अनि त्यसले गर्दा चाहिँ नर्दन सेक्सन चाहिँ हाम्रो माथि शिवालिक जोनको नजिक परेको हुनाले चाहिँ, अनि वाटर केमिस्ट्री पनि त्यस्तै आएको छ, क्याल्सियम म्याग्नेसियम टाइपले, अनि त्यसले चाहिँ हाम्रो यस्तो डोलोमाइट लाइमस्टोन बियरिङ जोनहरू हुन्छ, अनि त्यसले चाहिँ आइरन कन्टेनिङ बियरिङ पनि बढी गर्छ, त्यो रिडक्स रिएक्सनहरू गरेर, अनि त्यसले गर्दा हुन्छ। अनि
हावर जोनमा एकदम कम भयो, फेरि तल फेरि तराईमा बढी छ,
पुरै तराई सेक्सन। अनि आर्सेनिकको पनि पर्सेन्टेज छ, यो चाहिँ मैले एउटा पार्ट मात्र थिसिसको राखेको, बाँकी सबै प्यारामिटर।
आर्सेनिकको पनि छ,
आर्सेनिक पनि छ, तर आर्सेनिक पनि छ, तर लिमिटमै छ। मैले स्टडीमा चाहिँ अहिले आइरन मात्र राखेको, बाँकी सबै प्यारामिटर पनि गरेको छ स्टडीमा चाहिँ, थिसिस होल थिसिसमा चाहिँ।
I have one query regarding the, you have taken two type of water sources, right? Deep and shallow. But in your data collection and interpretation and result calculation, you got the value of iron content in shallow lies between 0.17 to 8, near about 8%, right? But in the same value you got it for the deep source of water, right? So what is the differences? What is the reason behind it?
In the deep sources, only one sample applied to more high values, like 7 point something. That sample is nearer to the more agricultural and the industrial area, so only in that sample the value is high, and as compared to the shallow sources, other sample were low than the shallow.
But actually your data shows the data ranges from 0.17 to 8 point something, right? It is large scattered data. So how it is represented to the real field? No.
So then you discuss during coffee break after the completion. Okay? So then I will invite the new speaker. You got 12 minutes to present.
So here I present a research study that only undergraduate students have led in the supervision of our professors, and our research title is Assessing the Lateral Groundwater Contamination Resulting from the Severely Degraded Kathmandu River, Kathmandu Valley, Nepal. Presentation that I would like to give the background of our study. So why did we conduct this study at the first place? Is because Kathmandu River is the pollution of Kathmandu River is not is well known to everyone. We smell, feel, hear about Kathmandu River, see the Kathmandu River pollution in our daily lives. So it called for an urgent need to discuss this pollution at the student level or at education level for us also. And this study was funded by SEG, Society of Exploration Geophysicists, and it provided us the technical support for conducting our research program. So this study, why is this study so anomalous than other studies? Because there are different studies conducted in Kathmandu River as well, but the study focuses on geophysical amalgamation with hydrogeological water quality analysis. So I feel this study has a geophysical approach to it. The objectives of the study studying lateral groundwater contamination and detecting of water quality parameters using water qualitative analysis of sample and groundwater samples. So our study area contained mostly of southern part from Gokarna to northern part Gokarna to southern part Chobar. The methodology we applied in our study were geophysical survey and water qualitative analysis, and also the rest study included of geological, groundwater, surface water, literature reviews. We also deployed the 2D resistivity method for our ERT survey, as well as water quality analysis parameters such as chemical parameters, physical parameters, and biological parameters. So our ERT surveys were conducted at Chobar, Teku, and Gokarna. Gokarna being one of a little of space from the other two areas, so we could conduct both. We could conduct ERT surveys on both the banks. But when we come downwards towards heavy settlement areas, we couldn't conduct ERT surveys on the both banks. So we majorly conducted ERT surveys on the left bank of Teku and Chobar. Water sampling sites. So we majorly took water samples from dug wells from 6 sites namely Uttar Bahini, Jorpati, Jagriti Nagar, Sahyoti Nagar, Teku Dobhat and Chobhat. So we conducted our lab test in NAST and KOKL labs. Altogether 144 samples were taken pre and post monsoon. 74 samples were taken in pre-monsoon and 70 samples were taken in post-monsoon. The decline in post-monsoon, decline of post-monsoon sample is because we saw Kathmandu Valley suffered a devastating flood on 26th to 28th September, which led to the burying of 2 of our dog well samples. So when it comes to result, we can clearly see that the pre-monsoon contamination has been diluted in the post-monsoon contamination profile. And when it comes to looking at the Piper diagram, we can see a major dominance of calcium and magnesium cation and the major dominance of carbonate and bicarbonate anions in the Piper diagram of Uttar Bahini. So in Teku Dobhan, as I said, there was a devastating earthquake that we faced in 28th to 26th of the September, which resulted in the dry compact field that we see here in the profile in post-monsoon. And the contamination is not really diluted. It's because maybe the infiltration that Bagmati River infiltration dam machinery was that Teku Dobhan has. Also we can see a similar trend in Teku Dobhan that the dominance of calcium and magnesium can be seen in the pre-monsoon water samples, whereas the sulfate, sodium and other anions can be seen in the post-monsoon, which may be the result of the anthropogenic activities. So when it comes to Chobhar, we can find out that the dilution of contamination in the post-monsoon season in our ART profiles, whereas similar trend can be seen in Chobhar Piper diagram as well. The higher concentration of calcium and magnesium is still intact with the dominance of calcium, carbonate and bicarbonate anions in the post-monsoon samples also. When we talk about physical parameters, we can see a decline a great extent of decline in physical parameters like alkalinity, pH, total hardness, TDS, whereas pre-monsoon has high amount of alkalinity, hardness and TDS. The chemical parameters in similar trend decrease in the post-monsoon in compared to.
You have 2 minutes more.
In compared to pre-monsoon, and you can see a very high amount of nitrate in Uttar Bahini River, which might be because of the agricultural practice done in these areas. And the oxygen demand and COD is very high in the areas of Uttar Bahini River sample and well sample, which might be because of the high nitrate content or agricultural practices and fertilizers use. So as a whole, when we look at the Piper diagram of all the water samples taken pre and post monsoon, we can find a dominance of calcium and magnesium anions and a dominance of carbonate and bicarbonate anions, which shows that there might be an which shows that there is a interaction between the dissolution of calcite, which is in the periphery of Kathmandu Valley, and the presence of sodium, chloride, nitrate are because of of the anthropogenic activity that's done in the mostly seen in the pre-monsoon. The higher concentration, as I already said, it might be because of the anthropogenic activities, or maybe because of the agricultural practice that is seen in the Uttar Bahini water samples evidently. While concluding the presentation, I would like to conclude it by saying that our result definitely shows lateral contamination when we look at the river samples and come away from the river samples towards the dog well samples. And ERT survey is definitely dependent on monsoonal rainfall. All the water samples definitely show a deep association of calcium and magnesium. Likewise, the BOD and COD is very interesting in our research, which also shows that Bagmati River is unable to sustain any kind of life forms in it. Here is a picture of our group.
Very good. So, you 14 authors, are you all students?
Yeah, we are undergrad. हामीले त्यस्तो मेजर चाहिँ गरेको छैन. डिफ्रेन्ट ठाउँमा डिफ्रेन्ट डेप्थ्सहरू छ. कुनै ठाउँमा उत्तर बाहिनीमा डिफ्रेन्ट डेप्थ्सहरू होला भनेपछि टेकुमा आएर डेप्थ्सहरू कम बढी हुन सक्छ. सो त्यसको बारेमा चाहिँ हामीले त्यस्तो रिसर्च गरेको छैन. हामीले चाहिँ
प्रायः जसो अब त्यो आयनिक फर्ममा निकाल्नु भयो कन्टामिनेसन
हामीले त्यो पनि प्यारामिटर्सहरू टेस्ट
त्यसमा राख्नुभयो. अब एउटा एकदमै ब्लङ क्वेसन सोध्नु पऱ्यो भने मलाई पनि कसैले सोध्यो त्यस्तै ठाउँमा त्यो बागमतीको पानी यसरी बगिरहेको छ, कति मिटर डेप्थमा गएपछि त्यो क्लिन हुन्छ भनेर सोधेँ. कति मिटर डेप्थमा चाहिँ पास भएर तल सोइलबाट मुनि गएपछि त्यो आफै स्वच्छ हुन्छ भनेर कसैले सोधेको. त्यसको जवाब
स्वच्छ त आई डोन्ट थिङ्क हुन्छ, किनभने हामीले जुन प्यारामिटरहरू हेरेको छौँ हामीले पोस्ट मनसुन अथवा प्री मनसुनमा हामीले रिभर वाटर स्याम्पलले डेफिनेटली डक्टरलाई अफेक्ट गरेको छ भनेर चाहिँ हामीले देखेको छौँ होइन. सो ल्याटरली कन्टामिनेसन भइरहेको छ भन्ने यो हाम्रो स्टडीले एभिडेन्टली देखाउँछ. सो म चाहिँ त्यो प्युरिफाइड नै हुन्छ वाटर जति डेप्थमा गए पनि इन्टायरली चाहिँ म भन्न सक्दिनँ त्यस्तो.
त्यसमा त केमिकल टक्सिक छ भने त कहिले पनि हुँदैन होला होइन.
हजुर,
केमिकल टक्सिक छ भने कहिले पनि हुँदैन होला. कस्तो किसिमको कुराहरू चाहिँ प्युरिफाई हुन्छ भनेर के भन्न सक्छ?
कस्तो
कुन कन्टामिनेसन कुन इम्प्युरिटीहरू चाहिँ प्युरिफाई हुन्छ, कुन हुन सक्दैन?
आई थिङ्क डाइल्युट हुन सक्ने कन्टामिनेन्ट्सहरू चाहिँ डेफिनेटली प्युरिफाई हुने चान्सेसहरू छ, किनभने वाटर प्लान्ट सिस्टमहरू पनि हामीले अहिले बागमतीको रिभरमा प्रायः जस्तो भएको इन्स्टल गरेको चाहिँ देख्छौँ. तर वेन इट कम्स टु लाइक केमिकल कन्टामिनेन्ट्स लाइक नाइट्रेट होइन, आर्सेनिकहरू, आइरनहरू त्यो पनि फ्लस आउट भएर गइरहेको हुन्छ. तर एभिडेन्टली कान से कि यसले नै हुन्छ भनेर चाहिँ म प्रष्ट भन्न सक्दिनँ, किनभने म त्यसको बारेमा रिसर्च गरेको छैन.
जस्तो लेटरल कन्टामिनेसन हुँदा तपाईँको एज पर लेन्थ त्यो कन्टामिनेसनको जुन कन्सन्ट्रेसन छ नि त्यो कसरी घटबड भएको थियो चाहिँ र उहाँहरूको पनि सरले जुन भन्नु पनि तपाईँले पनि भन्नुभयो यो ओन्ली ड्यु टु बागमतीकै कन्टामिनेसन हो भने त्यो चाहिँ हामी भन्न सक्दैनौँ. जस्तो अब हाम्रै ढल चाहिँ त्यति राम्रोसँग जस्तो भएको छैन. त्यसको कन्टामिनेसनको प्रोपोर्सन कति त्यसले गरेको रेसिपी के हो त्यो चिज चाहिँ एनालाइज गर्नु पनि भयो.
हामीले 50 मिटर्सको इन्टरभलमा गरेको छौँ ल्याटरल कन्टामिनेसन चेक गर्नलाई. डगवेल स्याम्पलहरू लिएकोमा चाहिँ 50 मिटर, 100 मिटर एन्ड 150 मिटरमा डगवेल स्याम्पल्सहरू लिएको छौँ होइन. सो त्यसमा चाहिँ के भएको छ भनेपछि हामीले रिभर वाटर स्याम्पलले चाहिँ मात्र गरेको पनि भन्न मिल्दैन तपाईँले भने जस्तै, किनभने हाम्रो पुरै भ्याली हेर्ने हो भनेपछि चाहिँ सिवेज पोल्युसन र जियोग्राफिकली पनि हामी काठमाडौँ यस्तो भ्यालीमा पर्छ जुन क्याल्साइडहरूसँग सराउन्डेड छ होइन. क्याल्सियमको पनि कन्टेन्ट, म्याग्नेसियमको कन्टेन्ट हाई भएको पनि कारण त्यही हो जस्तो भन्न सकिन्छ. तर स्टिल हामीले त्यो प्यारामिटर चाहिँ यसरी टेस्ट चाहिँ गरेको छैनौँ कि म एक्ज्याक्ट भन्न सकोस् तपाईँलाई चाहिँ कति रिभर वाटरले गरेको हो र कति एन्थ्रोपोजेनिक एक्टिभिटी हो र कतिको कन्टामिनेसन मैले हेर्न भ्याएको चाहिँ मैले एक्ज्याक्ट भन्न सक्दिनँ. तर डेफिनेटली रिभर वाटरले मात्र हो भनेर पनि भन्न सकिँदैन, अरूले पनि हुनसक्छ.
Thank you.
Thank you so much for giving us this platform. Thank you.
So then now I call upon Praveen Kalapati. He is going to present his title is Assessment of Shallow Groundwater and River Water Interactions.
Assessment of the shallow groundwater and river water interaction in Geological Nepal.
Could you please don't talk behind?
And we know that groundwater is the water that exists on surface, the force and the capture of soil and rock formation. And groundwater quality is influenced by the water. Also, there is condition interaction between the water and the rocks. Historically, groundwater behavior interaction has been poor to the surface water integration plan. Therefore, groundwater management need better joint planning with the surface water development plan, particularly for the water supply utilization, which is still historical section and water demand. Here is my profession. My study area lies in the part of Ratnanagar and part of the Bareilly municipality of Chittagong district, Nepal, Baghmati province. And geographically, it is bounded by given latitude and longitude, and topographical number is present here. My main objective is to explore the relationship between the river water and the groundwater in the segment of Budirathi River, and to investigate the seasonal variation of insulin parameter of shallow groundwater river and the Budirathi River. My methodology include institute measurement of 52 different shallow well location and 19 location of river water, along with the hydrographical parameter all together from the shallow draw well and the seven from the river channel. And here is my sampling location where I use the hydrochemical parameter. And here it is a parameter test using laboratory analysis and method. I took 12 parameter test at Geological. And here is a photograph during field travel. And these are the discussion. Budirathi River originated from the series of spring of Kuche forest in the south eastern Chittagong Valley, and it is meandered parallel to the Rapti Nadi, where it made downstream. Koya Kola and the Kaveri Kola is minor tributary play vital role in the charge of the Budirathi River, and it is the vital source of irrigation for agriculture, particularly in the Pasira and PLC of the study area. And we can see people utilize pump from the surface area Budirathi River, like river water or irrigation. And the study area, the river condition are primarily characterized shallow unconfined river, sediment like silt, clay, and gravel. And shallow well are commonly utilized in the area, providing for water for agriculture and domestic purpose. You can see in the photo also. And the flow direction of groundwater, data from the shallow well is collected from the GIS, from a water level map, water contour map, which shows the multi-direction flow of shallow groundwater during post-monsoon and the pre-monsoon. And the river water acts in both discharge and the recharge area. And the statistical analysis of the institute river water quality parameter, both groundwater and the river water is calculated. Both parameter, temperature, C and pH, here is measured. This is the volume plot of seasonal variation of insulin parameter. We show the distribution and the density of the co-parameter, which I call it during both seasons. Identification of shallow groundwater and the river water interaction. From temperature profiling during pre-monsoon, I measure water sedimentary phase temperature, river temperature, and the groundwater temperature. We saw that majority of the my field study site losing stream in which river water and the groundwater has similar temperature. However, at basic region, water sedimentary interface temperature is very closely aligned with the groundwater temperature. We saw that basic region has gaining stream. Here we can see the photo also where sequence of the groundwater into the river water at basic region. And comparing the mean sea level elevation from the upstream to downstream, our shallow groundwater level and the river water elevation. We can conclude that most of the area of my study area are in the losing section, however in some section there is closely aligned. We saw that here clearly the balance between the gaining and the losing stream depend upon the minor change or seasonal change. And from the institute parameter, the statistical analysis of institute parameter from the box and Wisner plot, so that there is an interaction between the groundwater and the river water. And from the hydrochemical parameter, so that average concentration of groundwater Kathmandu and Anand is greater than the river water. We saw that river water is seepage into the from the river bank, river bed to the groundwater. And this is the pattern linear diagram. We saw that majority of the groundwater and the river water falling into the mixed type. We saw that same water type classification, which reveals that there is a strong interaction between the river water and the groundwater. In conclusion, the analysis of groundwater flow pattern in both pre-monsoon and post-monsoon revealed multi-direction flow direction of upstream to downstream. And the study identified significant interaction between the groundwater and river water, indicating that river function as a losing stream, especially during pre-monsoon period. And this is supported by the temperature data. And hydrochemical analysis also shows similar ion concentration in groundwater and river water, with bicarbonate as a dominant ion. I like significant chemical interaction between these sources, and the pattern diagram further support this by classifying both as a mixed water type indicating historic interaction. I like to acknowledge following person and institute. And thank you.
So we have some time for the question and answers.
To the absence of my co-author, Mr. S.R. Shrestha, I am here to present this our paper, and many others. Previous paper focused on the academic types of paper. Now this is a techno-management type of paper. I think you will enjoy in my presentation, and I am hopeful that you will give suggestion and feedback on this techno-management type of paper. Main challenge in groundwater is one of the challenge in groundwater, especially the paper focused on the context of Nepal. So, challenge in groundwater ownership issue. In our constitution, all natural resource belongs to the government, but groundwater and other resources belong to their own property, private sector properties. There is some more difference, and ownership of groundwater is not well defined. We know that groundwater is not visible in the surface. Sometimes use of groundwater in your land may affect the others, right? Other precise use of the groundwater. So this is one of the challenges. And other challenge facing in Nepal is the fully authorized national organization. This is one of the challenges. To authorize the use of the groundwater in the context of Nepal is another challenge. And other challenge is intensive groundwater development without appropriate resource management. We are not focusing in the groundwater basin management. We are only using how to benefit from the groundwater resource. We in Nepal, as this standing in front of you, I want to say that we have no appropriate groundwater management plan. So this is one of the challenges in the management of groundwater resources. And other challenge is licensing for well drilling and groundwater use. Especially in Kathmandu Valley, there is KVKL, Kathmandu KVKL has some authorized, and they are not doing well, but they are authorized to have some technical guidance there, but outside the Kathmandu Valley, not all in Kathmandu Valley, outside the Kathmandu Valley, licensing is not being applied in Nepal. And climate change and its impact on the recharge process. This is not only climate change, and other recharge process is being decreasing. We are using recharge area and different type of use. We have payment of the recharge area. We have a Churia Shivalik zone is one of the recharge area, and we have no well-planned management to save the recharge area. And other challenge is non-professional contractor. We want to have a professional contractor to use the groundwater, but there is one of the challenge we are facing non-professional contact, professional contact, and another thing is poor groundwater monitoring and data collection. There are some of the plan to have a monitoring. Now we have only the groundwater level monitoring, not all recharge and exploitation and exploration process is lacking here. This is the challenge we are facing. And challenge is groundwater, lack of community awareness and participation. These two photos, we can see the third one, groundwater, mainly government of money from government has used this groundwater table. Now you can see this land is for sale. So this is not only groundwater irrigated area, but there is also some problem that irrigated area being changed in the non-agriculture land. So that this is one of the being challenge for the use of the groundwater, especially in the irrigation sector. And challenge in groundwater exploitation is water conflict and inadequate indices, groundwater for irrigation and domestic water uses. In our priority, in our water resource policy and water resource act, we have priority on the domestic use. But there are sometimes there is some issue which is the main priority for the use of groundwater, and sometimes we are using deep tubewell instead of shallow tubewell. We are not focusing about the groundwater management aspect. We want to use availability of the ability of the aquifer. Either it is available in the, if we found the shallow aquifer, we want to use the shallow groundwater. But this is not a scientific groundwater management aspect. We have to overall groundwater basin. We should consider overall groundwater basin so that we can use deep aquifer and or shallow aquifer as per the management. And conservation groundwater recharge zone area of sustainable groundwater resource is one of the major issues. Now it is one of the challenge in the, especially in the Kathmandu Valley. We are facing the depletion of the groundwater level, groundwater, water table, and other resources also depleting here. And as groundwater potential, we are only 1/4 of the groundwater resource, especially in the Taurine region. we are using groundwater resource. Nepal has 13 million cubic meter renewable groundwater resource. The potential could irrigate more than 725,000 hectare of the land, and irrigation master plan, the latest one irrigation master plan, there is clearly mentioned that 725,000 hectare can be irrigated through groundwater. Now, till now, more than 300 hectare of the land is being irrigated by the use of groundwater. And other positive thing that comparatively groundwater, there is high economic return in the groundwater, mainly in the Tarai region. We have more costly in the mountain region, but comparatively economic rate of return and gestation period is very low compared to the surface water. And potential, beside this, in Nepal, there is potential of expansion of hills and mountains. Now, after more than 1 decade, Nepal government is focusing on the use of groundwater in the mountain, especially water resource, Ministry of Water Resources is focusing on the river basin use of groundwater. So this is the potential for the hills and mountains. And Department of Water Resource and Irrigation is have one of the major project focusing on the use of the in river basin master plan and a river basin development of irrigation system. And other important thing, we are using the conjunctive use with surface water. So there are many areas which area we have only sufficient water for only 4 months, and beside 4 months we can use groundwater in the surface irrigated area.
Listen. Thank you, Kilasar. Now I would like to request our President to hand over the token of appreciation to Reporter Mr. Arpan Parajuli. Thank you for being here.